Hi students, problem number 18 is based on the application of Gauss law. An infinite line charge produces a field of 9 into 10 power 4 Newton per Coulomb at a distance of 2 centimeter. Calculate the linear charge density. First of all, what do you mean by infinite line charge? If you take a thin wire which is very long, the length of the wire is very long, means very large in comparison with the diameter or the radius of the wire, then it is called as a infinite line charge. So it's a charge density, okay, linear charge density is asked. Now you must have studied in the derivation of the electric field due to infinite line charge at any point distant r. I have taken such points, you can see. So these are all the different points which are equidistant, okay, equidistant from the center, that is at a distance r. So the electric field is radially outward if it is a positive line charge. So you can see here positive charges are lying on the outer surface of the wire, and this creates an electric field at all points equidistant from the center. If you join means it forms a circle and it is radially outward. So this electric field is created by the line charge and it is given as what, 9 into 10 power 4. So the electric field intensity is equal to 9 into 10 to the power of 4 Newton per Coulomb. So at what distance r is given? R is given as 2 centimeter. So this is 2 centimeter. This can be written as 2 into 10 power minus 2 meter. And what do you mean by linear charge density? That is denoted by lambda, the total charge divided by length. Okay, so this is called as linear charge density. This only we have to determine. Now we have studied this application and we have derived an expression. Electric field E is equal to lambda divided by 2 pi epsilon naught into r. So what is the magnitude? What is the magnitude of this electric field at a point distant r from the center? At a distance r from the wire, what will be the electric field that is given by this formula? E is equal to lambda divided by 2 pi epsilon naught into r. Now I can modify this. I can modify this as multiplying and dividing by 2. This becomes 2 lambda divided by 4 pi epsilon naught into r. Always it is better this pi into epsilon naught should have a prefix 4, then only 4 pi epsilon naught value can be easily remembered. Is it not? 4 pi epsilon naught, what is its numerical value? It is 9 into 10 power 9. Is it not? That is why. So from this equation we have to determine the value of lambda. The value of E is given, the value of 4 pi epsilon naught, r its reciprocal, we know it, and the value of r is given as 2 centimeter. So E, in place of E, I am going to substitute 9 into 10 power 4. So on the left hand side it is 9 into 10 power 4 is equal to 2 into lambda divided by, okay, r into 1 by 4 pi epsilon naught, okay, into 1 divided by 4 pi epsilon naught I am writing, divided by r. So what is r also we can substitute. R is equal to what? 2 centimeter, or 2 into 10 to the power, okay, 2 into 10 to the power of minus 2. So 9 into 10 to the power of 4 is equal to 2 and 2 get cancelled. So lambda into 1 is lambda divided by 10 power minus 2 into 1 by 4 pi epsilon naught. I can substitute now 9 into 10 to the power of 9. So that this factor 9 also can be cancelled. Remaining only 10 powers must be adjusted. Okay. Or now lambda value is equal to, lambda is equal to this 10 power 4 multiplied by 10 power minus 2. 10 power minus 2 into Okay, this 10 power 9 is coming to the denominator. Okay, it is coming to the denominator. So this is divided by 10 power 9. So if this comes up means it will become 10 power minus 9. So lambda is now equal to 10 power 4 multiplied by 10 power minus 2 into 10 power minus 9. So 9 and 2 makes minus 11. This is a plus 4. Or lambda is now equal to, okay, lambda is equal to 11 minus 4, that is 7. 10 power minus 7. Okay, the numerical value is 10 power minus 7. But what must be its unit? The meaning of linear charge density is a charge per unit length, is it not? So coulomb per meter. The unit must be equal to what? Coulomb per meter. Okay, I hope you must have understood this well. Fine.